Yeah, welcome to electrolysis topic. In this, splitting of ionic compounds, molten liquids, ionic solutions and discharge rules, Q is equal to LT and oil or rig, brine and purifying copper solution. For the splitting of ionic compound 1, see this ionic compound 1, sodium chloride, sodium ion, chloride ion, how they are present. See, sodium chloride crystal structure it is. Ionic compounds are made from positive ions, atoms which lost negative electrons, negative ions, atoms which gain negative electrons. As these ions have opposite charges, they attract each other strongly to form ionic bonds. Splitting up ionic compounds to two ways to split up ions, that is melting at 800 degrees Celsius sodium chloride, at 20 degrees Celsius dissolving in water. Separating the ions, electron, metal electrode. See, this is how battery pulls electrons off one electrode and the pushes them into other electrode. This is the sort of electrons so become positively charged anode. Left side, right side. This as extra electrons becomes negatively charged cathode. See, that's why this left side we have positive, right side we have negative. Separating the ions. So anode, cathode, molten ionic compound taken, and a battery is switched on. Positively charged ions go towards cathode, negatively charged ions go to anode. This gives up a way to split up ionic compounds. This is called as electrolysis. Example 1. Splitting up molten sodium chloride salt. So chloride ions are Cl minus anode. Chloride ion is 1 electron extra with a green color, and chlorine atom neutral without any green color electron. Chlorine gas is liberated at anode 1, it loses electrons. Of that, sodium metal is deposited at cathode. See how chlorine gas is liberated at anode. Yeah. Next, this way sodium metal, neutral sodium metal is deposited at cathode. Next, splitting of molten sodium chloride, Cl minus ions towards anode as that is positive. Sodium ions move towards cathode as it is negative. At anode, Cl minus gives Cl gas. At cathode, these electrons move towards cathode. Their sodium ion gets deposited and undergoes reduction. Splitting up of molten lead bromide PbBr2. Br minus towards anode, Pb2 plus towards cathode, and in this bromine gas liberated at the anode. At cathode, lead is got deposited. What happens when ionic compounds are dissolved in water? Here water molecules breaks up into hydrogen ions, H plus and hydroxide ions, OH minus. So in an ionic solution, sodium chloride solution example, there will be 4 types of ions present. 2 from the ionic compound and 2 from the water. Sodium chloride aqueous solution. Now to take ionic solution, each ions gain and lose electrons, get discharged, it stay in solution. So now we observe. There is a question. Towards anode we have Cl minus and OH minus ions. Towards cathode H plus and Na plus ions are there. So which will get discharged, which will gain lost electrons, which will stay in the solution. It's a question. Now, so hydrogen is less reactive than sodium. It is discharged and the sodium ions stay in solution. Next, if negative ion is halogen, it is discharged and chlorine is given off and the OH minus ion stay in solution. Ionic solutions, cathode is non-halogen compounds are there, nitrate, oxoanions. Then whether mix oxoanions liberates or OH minus ion liberates. See, if negative ion is not halogen, example nitrate sulfate, then hydroxide ions from the water discharge to make water and oxygen gas. The other ions stay in solution. Rules for ionic solutions. Anode, cathode. Anode acts negative ion. Cathode acts as positive ion. If negative ions are halogens, chloride, bromide, iodide, the halogen is produced. If negative ions are not halogens, sulfate, nitrate, carbonate, then oxygen is produced. If positive ions are more reactive than hydrogen, sodium, potassium, calcium, magnesium, zinc, iron, hydrogen is produced at cathode. If positive ions are less reactive than hydrogen, copper, silver, gold, then metal is produced at cathode. Now these are the list of the compounds obtained at cathode and anode in the electrolysis. Potassium chloride gives potassium and chlorine. Aluminium oxide, aluminium oxygen. Copper chloride, copper and chlorine. Sodium bromide, hydrogen and bromine, aqueous solution. Silver nitrate, aqueous solution. Silver and oxygen. Potassium chloride, hydrogen and chlorine. Zinc sulfate, hydrogen and oxygen. Electrolysis makes a circuit. Complete electric circuit. Current carried by electrons in electrodes provides ions in electrolyte. To double the mass of substance discharged at electrodes, we raise the current 2 into current. 2 into battery voltage, 2 into time current flows for Q is equals to IT. Oil rig, oxidation is loss, reduction is gain. Loss of electrons become atoms called oxidation. Even though oxygen may not be involved. Ions gaining electrons become atoms called reduction. So oxidation is loss, reduction is gain. That is called oil rig. Industrial uses of electrolysis. To extract reactive metals such as aluminum, sodium, magnesium, etc. from their compounds. This is expensive due to large amounts of electrical energy is needed. Aluminum is extracted from bauxite. Electrolysis of brine salt solution to produce chlorine for disinfectants and plastics. Hydrogen for ammonia, fertilizers and margarine. Sodium hydroxide for soap and cleaning agents. Purifying copper. Copper for wiring etc. needs to be more pure than produced in a blast furnace. Electrolysis is used to convert pure copper to pure copper, impure copper to pure copper. Industrial electrolysis of brine solution. At anode, OH minus and Cl minus will come. At cathode, H plus and Na plus will come. Chlorine gas liberates at anode. OH minus left in solution, so concentration grows. Hydrogen gas liberates at cathode. Na plus left in solution, so concentration grows. Sodium chloride solution neutral, slowly change into sodium hydroxide, which is alkaline. This is industrial chlorine production from electrolysis of brine solution. Purifying copper. Impure copper rod is anode. Pure copper is cathode. Is copper sulfate solution is present. Copper atoms from impure copper are oxidized to copper ions. Copper ions transported from anode to cathode. Copper ions from impure copper are reduced to copper atoms. As the atoms of impurities are not transported, that copper that builds up on the anode is extremely pure. So impure copper anode, rod observed dissolves. An impurity sink to the bottom. A pure cathode grows a more pure copper is deposited on it.